Okay, so last time we filled this in for arsenic. We started at the bottom, and these represent the electrons. We filled it in, and we got all the way up to the last spot for arsenic, which is 4p3. If you look on the periodic table and go across, that's where its coordinate would be. Okay, so the next thing that we need to do is write this out in a way that's more condensed, and it's called electron configuration. And the idea behind this is kind of like where every electron is in the atom. So when you write this out, you're going to tell me where every electron is for arsenic, all right? And we start at the first energy level, right? And you know, just from the top of your head, how many electrons are in the first energy level? 2. So the way we write that is we look here, and this is 1 for the energy level. This is S, and that's the orbital, all right? And there's 2 electrons in there. So we would just write it as 1s2, all right? You can just write it at the bottom somewhere, all right? Then we go to the next energy level. Because remember, the first energy level can only have 2. So we go to the second energy level, and overall the second energy level can have how many? It can have 8, yeah, exactly. So we need to say where those 8 are, though. 2 of them are in the S, and then 6 of them are in the P's. So the way we write this would be the same thing that we did here, but now it's 2s because we're in the second energy level. So it's 2s, and there's 2 of them. And then we do the same thing for this. 2p, and there's 6 of them. All right, so we're just kind of writing down everything that we had there. All right. Now we go to the third energy level, right? And so 3s, 2. All right, we go to the next thing, which is 3p, 6. All right, and then we go to the next one, which is 4s2. 4s comes before 3d. It's a little bit lower energy. So I know it looks a little weird, but then we do that, 4s2. Then we jump over to the 3. 3d10. There's 10 in there, and then finally we have 4p3. So this shows you how many electrons are in each energy level, that's the number. What kind of orbital those electrons are, that's the S or the P or the D. And then how many are in each of those orbitals, and that's the number on the top, the superscript. If you were to add up the superscripts, they should equal the number of electrons, which is the number of protons for the element that you're doing. So in this case, arsenic, if you add these all up, you should get 33, because that's what arsenic's number is. Okay? Cool? You see how we wrote that down? Okay. Next time I'm going to show you how to do the same thing, but from just looking at a periodic table. So you don't have to draw all of these arrows out. You can just look at a periodic table and figure it out. All right? Stay tuned.